Hello everyone, this is Chemniverse, and here, we are today to discuss the differences between SN1 and SN2 reaction. First of all, let's not forget to know what the symbols really mean. In the symbol SN, S represents the word substitution, and N represents the word nucleophilic. Therefore, the symbol SN represents nothing but the name of a very important type of organic reaction, nucleophilic substitution. Nucleophilic substitution reactions are the reactions where a nucleophile attacks a positively charged center to replace a leaving group from the substrate. By now, you must know that nucleophiles are electron-rich species that are produced by the heterolytic dissociation of reagents and seek positive centers to attack. SN reactions are of two types. Number 1, SN1 reaction. Number 2, SN2 reaction. Number 1, SN1 follows a two-step mechanism, whereas SN2 follows a one-step mechanism. Two steps are involved in SN1 reaction. In the first step, a carbonium ion is produced, which is in the second step attacked by a nucleophile. The first one is the slower step, and hence, is the one that determines the rate of the reaction. On the other hand, only one step is involved in the SN2 mechanism. So, we can say that the mechanism here is concerted. The nucleophile attacks the carbon atom from the opposite side of the leaving group and simultaneously, the leaving group leaves. However, an intermediate complex is formed in case of SN2 reactions. Number 2, reactivity order of the substrate is opposite in SN1 and SN2. Both in SN1 and SN2 reactions, the substrate involved is alkyl halide. In case of SN1 reactions, the reactivity of alkyl halides decreases from primary to tertiary. On the contrary, reactivity of alkyl halides increases from primary to tertiary when it comes to SN2 reactions. Number 3, SN1 is a first-order reaction where SN2 follows second-order kinetics. In case of SN1 reactions, the reaction rate only depends on the concentration of the substrate, alkyl halide. But, in SN2 reactions, the reaction rate depends both on the concentration of alkyl halide and the nucleophile. The number 1 and 2 used in the symbol SN1 and SN2 symbolizes first-order and second-order kinetics respectively. Number 4, attack by a strong nucleophile favors SN2, and that by a nucleophile favors SN1. SN1 reaction generally proceeds with weak nucleophiles, such as ethanol, methanol, water. SN2, on the other hand, proceeds with strong nucleophiles such as methoxy ion, hydroxyl ion, cyanide ion, etc. Number 5, high concentration of nucleophiles favors SN2 reactions, and SN1 mechanism is independent of nucleophile concentration. We know that SN2 is a second-order reaction, which means its reaction depends on concentration of both substrate and reagent. Therefore, when the nucleophile's concentration is high, SN2 is preferred over SN1 mechanism. As SN1 follows first-order kinetics, and the rate of reaction does not really depend on the concentration of the nucleophiles, SN1 proceeds with nucleophiles having any concentration. Number 6, carbocation forms only in SN1 mechanism. It has been mentioned earlier that the first step involved in SN1 reaction is the step where a carbocation is formed, and that carbocation is attacked by a nucleophile in the second step. There is no such carbocation formation in case of SN2. Number 7, Walden inversion takes place only in SN2 reactions. Walden inversion is nothing but the inversion of a chiral center. Walden inversion occurs during an SN2 reaction. It is compared to an umbrella just turned completely inside out. In an SN2 reaction, the configuration of the product is opposite to that of the reactant because of this sort of inversion. No step in an SN1 reaction involves Walden inversion. Number 8, factors affecting kinetics of SN1 and SN2 are different. Kinetics of an SN1 reaction are mainly determined by electronic factors. The rate of the reaction is proportional to the stability of the carbocation. On the contrary, kinetics of an SN2 reaction depend on steric factors. The less the steric hindrance, the faster the reaction will be. Number 9, SN1 reactions are favored by polar protic solvents, whereas SN2 reactions are favored by polar aprotic solvents. Polar protic solvents such as water, alcohol, etc. favor SN1 mechanism, as these solvents stabilize the carbocation. Polar aprotic solvents such as dimethylformamide, dimethyl sulfoxide etc. favor SN2. These solvents dissolve both the substrate and the nucleophile, but do not take part in hydrogen bonding. Number 10. Molecularity is different. SN1 is of a unimolecular reaction whereas SN2 is a bimolecular reaction. Number 11. Stereochemistry of SN1 and SN2 is not the same. Both inversion and retention is involved in SN1, but only inversion is involved in SN2. So, that's all for today.